Hello everyone, and welcome to part 2 of how to make Pong in Unity. So last time we got our player moving from the top to the bottom of the screen, and now I would like to make it so the ball has its logic where it bounces off the paddles. So I'm going to start by creating a script for our ball. So, new script, let's name this ball movement. And the way I want my ball to move is that at the start of the game, it will choose to move left or right, and then based on where it hits the paddle is the angle it will launch. So if it's like directly in the center, it will launch the other way. But if it's closer to the bottom, it'll launch downward. So just to create a bit more randomness with how the ball will move around. So let's add a rigid body so we can, oh darn it, add a rigid body so we could make it move around the screen, turn off the gravity, and we want it to be at a fixed angle. And now we can get it to start doing what we want it to. So as I said, I want it to move either to the left or the right when we start. In order to do that, I am going to create some code in the start function to make it do that. And we're going to have int rand equals random.range. I'm going to have it go anywhere between 0 and 2. And the reason why I do 2 as the maximum is because these are going to be integers. And integer type variables cut off the value. So if it generates the random number 1.94, which is really close to 2, it's not going to be 2. It's going to go down to 1. And if it generates 0.5478, that's going to go down to 0. So this only has two different possible numbers that it can become. So if our random value equals 0, it's going to move left. Otherwise, if our random value equals 1, it's going to move right. So once again, we're going to access our velocity component, or rigid body component, and modify the velocity and set it to a new vector 2. And this time I just want to change the x components so it can move left or right. For this, I'm going to make it move left at a speed of 5, and I can change this later on if I see fit. And I'm going to make it move right if it got to 1. So I'm just going to test it to see if it can move left. So it's moving left, moving right, left. Okay, yeah. Seems pretty random. But the thing about random variables, they can never tell if it's truly random. Now, as you may have noticed, when it hit this, it just slid the back a bit. I want these to remain stiff and on their spot, and I want this ball to bounce back. I don't have to make it bounce in the code. I can create a physics 2D material, which is found down here, and let's just name this our ball. And I can set the bounciness to 1, and this bounciness value is a percentage of how much of the momentum will be transferred after the bounce. Okay, that's not supposed to happen. And to make this not move, I'm going to make this mass just a really big number. And that goes for both of them. Okay. Fixed angle, gravity scale of 0. Okay, now it's bouncing off. And The reason why it didn't last time is because the momentum got transferred into our bat here. So, now we have our ball moving. Although it's not really exciting because it can only move in this fixed area. Mostly. Anyway, what I want to do is make it so the ball bounces at a different angle depending on where it hits the bat. Like if it hits here, it should be launched downward. If it hits here, it should be launched upwards. And if it's in the middle, it should keep flying straight. So my plan for doing that is a bit complicated, and because of that I'm not really sure if I will be able to finish it by the end of this video. So, making the ball move around might be a two-part thing. Anyway, what I'm going to do is have the ball check the coordinates of the bat, and then based on that, it will change the y component and the x component of its velocity. So I want it to have a fixed speed of like 5. So let's start by generating some pseudocode, or just common center code, to figure out what we want to do. Now in our update function, we're going to control how the ball bounces back. So if you hit the endpoint, it should be going up or down at a fast speed. If you hit the middle, little to no change in the y velocity. And this is just going to go over different extremes. But here's the thing. I only want to change its velocity when you collide with another object, or specifically the bat, which is why I need the function on collision enter 2D collision 2D. I believe that's how it goes. Oh, I forgot the identifier. And this is really just the name of your on collision enter function. Or at least that's how I like to see it. So since I'm doing all my changes here, I'm going to move my pseudocode into the on collision. Now what I want to do is change the magnitude of the y velocity based on your position relative to the bat's center, which is down here. So in our on collision enter, I am going to create a value named distance, and we're just going to subtract this dot transform dot position dot y minus game object dot find, and this is named bat1 dot transform dot position dot x. And for debugging purposes, I just want to print distance. And using this value, we are going to figure out how much we want it to change. Okay, that's supposed to happen. And that's because I named it wrong. It's capital B. Anyway, using the value that we generate here, when it hits the bat, we're going to change up the magnitude. Okay, it's not changing. Okay, it was supposed to be distance dot y. But you get the idea. And using this, we will be able to change the magnitude of the velocity in the y direction in order to create fancy ball movement. And I ran out of time for completing the ball's movement, so that will have to be continued in the next episode. Thank you for watching, and goodbye.